all. So this lesson today is going to be about small increments or approximate change, which is another application of the differentiation topic that we're doing. So what we're going to do is going to take a look at the function y equals x squared, and we're going to focus in on a particular point, which is the 3,9 point there. So you can see in blue is the y equals x squared function, and in red I've drawn the tangent line at that point. So what I'm going to do first is I'm going to work out what the gradient is of this tangent line, okay, or what the gradient is of the function at x equals 3. So in order to do that, I need to do dy by dx. I need to take the derivative of the original function, which is going to be 2x, and then at x is equal to 3, I can plug it in to my gradient function, and that tells me that at the point where x equals 3, the gradient of the function is going to be 6. So if I was going to work out what the tangent line was, then basically I'd be just substituting that 6 value into the equation of a tangent line. Obviously the equation of tangent lines are always y equals mx plus c, so the m part would be just 6. And then I could go further and then work out what the c value. Anyway, I don't need that at the moment. I'm just going to focus on the gradient at x equals 3. So what I want to do is keep this at the back of my mind the whole time today. So when x equals 3, the gradient of this function, the blue line, is going to be equal to 6. And then I'm going to focus in on this point here, okay, and see what happens. So here we can see we've focused in a little bit more, so I've changed what the scale is. So now between 2 and 3. And you can see what's happening is the original function, remember, was this blue one, which was this y is equal to x squared, and the red one was the tangent line. And we can see that the tangent line is slowly disappearing. Basically, it's underneath the blue line of the function, isn't it? And if I go even further, zooming in, then we can't actually see the red line at all now. We can't actually see the tangent line. So we can say that actually the gradient, when we zoom in, of this blue line is basically going to be the same as the gradient of the tangent line. And that's what this small increments is all about, or approximate changes. So we can say that between, like I could choose another point like this one, for example. Let's do it in black so it's a bit clearer. So this point here, if I was to do this change in x, then this minimal change in x, and at this stage it's like 0.01, we say it's like delta x, which is strange, kind of like D shape. And this change in the y, all the way up to here, we say is this strange delta y. So then if I was going to work out what the gradient is then of this part here, then I'd be doing the delta y over delta x to work out what the gradient is, the rise over run, obviously. And because the blue line is on top of the red line, and you can't even see the red line now, can we? Because they're approximately the same. We can say that this is going to be then approximately the same as the gradient of the function at a certain value for x. And in this case, our original one was going to be 6, wasn't it? Because we were focusing on when x is equal to 3. Okay, so that's the important part of it. I can actually show you as well that it is going to be more or less the same thing. So if we take our original function then, and let's say that this one is going to be the x1, y1, and this point here is going to be the x2, y2, and work out what the gradient is then of this this black triangle, then it's going to be y2, which is the 9.06 minus the y1, which is 9, divided by the x2 value, which is 3.01 minus the x1 value, which is 3. And if we do that on a calculator, it's 6.01. Okay, so we can see that this 6.01 is approximately equal to this 6 then, and the closer I get to this x equals 3, so if I zoomed in even further, then it'd be approximately even closer to the original value. And that's the whole principle behind this thing. So now what I'm going to do is I'm going to show you an example of how to do this. So here we've got a typical example then. Given that y is equal to 12 minus 4x all to the power of 5, find dy by dx. So we'll find the derivative of this function then first. So question 1, let's use black pen. Dy by dx is going to be equal to, well, we've got the chain rule, haven't we? So we'll bring down the power, so 12 minus 4x to the power of 4, and then we have to times by the this u function, or if you remember, we were using a board rubber to do this, times by this thing differentiated, so that was going to be minus 4. So that'll give us minus 20, and then 12 minus 4x to the power of 4. So that's the dy by dx. So that gives us 2 marks. I don't think we need to multiply this out. I think that's going to take too much time. Part 2 then. So this is going to be the small increments part. Hence, find an approximate change in y as x increases from 0.5 to 0.5 plus p, where p is small. Okay, so if we remember then, we have this delta y over this delta x is going to be approximately equal to dy by dx at a certain value for x. And what is our certain value of x then? Well, a certain value of x is going to be this 0.5, because all we're doing is just adding this small p value onto it, or this is basically going to be the delta x, isn't it? That's what that's going to be. So we're needing to find an approximate change in y as x increases. So we could actually just rearrange this and say that delta y is approximately equal to dy by dx times by this delta x. Remember, this dy by dx this is only going to be valid at this certain value for x. So we need to find out what dy by dx is then at x is equal to 0.5. So we'll have to plug this value into it. So dy by dx is equal to minus 20 into 12 minus 4 times by the 0.5 to the power of 4. Okay, so I'm going to have to use a calculator here, so just use your scientific calculator and work it out. And this is going to be minus 200,000. Okay, so when you plug that 0.5 into that, you find out that the gradient, where x is equal to 0.5, is going to be equal to minus 200,000. Seems a big number, but that's it. So now this delta y, this approximate change in y, is going to be equal to this minus 200,000 times by our approximate change in x. Remember, I've just plugged, all I've done is just basically plugged with minus 200,000 into this, where this here was the minus 200,000. So approximate change in x then, we've already said is going to be this p-value. So approximate change in y then, this delta y is going to be minus 200,000 times by p. And that's it basically, we're done. So it seems complicated, but if you understood the first part of the video, then this should be pretty straightforward. All of these are pretty much the same, so just go ahead and have a practice at some of the questions now.